Okay, so we decided if there's one person, you could have zero handshakes, right? If there's two people, you could have one handshake. If there's three people, you could have three handshakes. 4, we modeled it and we figured out there's 6. 5, we modeled it, we figured out there's 10. And we represented these with the little diagrams like this, and a triangle, and then a quadrilateral with 4 connections, and then a pentagon, 1, 2, 3, 4, 5, with 10 connections, 1, 2, 3, 4. Which one am I missing? This one to here. Okay? So you can see that, like, from the first diagonal, I could draw 2 other connections, right? From each diagonal. But once I've used, some of them get used twice, so I can't count them twice. So that's why this would be 5 times 4 divided by 2, which would be 10. And we figured out the pattern. So for the 6th, we did do this. For 6, it would be what? 6 times 5 divided by 2, which is 15. So if I went dot, 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 and I wanted to figure out how many handshakes are there, how many different handshakes in this classroom? Say there's 30 students in this classroom, how many different handshakes could I have? How would I figure that out, Ashley?
I got 870.
How'd you get that?
I did 30 minus 1, which is 29.
Right?
And
Multiplied by
30.
Yeah, so 30 times 29, and then what do you do with that?
Divided it by 2.
Divided it by 2. And what do you get?
870.
870, that sounds about right. So we figured out that the formula for n people is going to be n times n minus 1 divided by 2, right? So if you had 100 people, 100 times 99 divided by 2. Don't forget that formula, because it's going to come up a lot, okay? What if I wanted to go backwards? Say I said, like, there were 171 handshakes. Is that the right? 171 handshakes. Handshakes. How many people in the room? How would I just set that up algebraically? How would I set that up algebraically? You have a formula. Go ahead, Kareem.
I was thinking,
Make an equation.
X times x minus 1 equals 1
Not
minus
n. Not x times x. I'm going to call it n. Just use a different variable. N times n minus 1
divided by 2.
divided by 2 equals 171. Right? So what do I need to do to get rid of that 2 on the bottom? Right, multiply both sides by 2. So if I multiply that side by 2 and that side by 2, I could cancel these out, and I get n times n minus 1 equals 2 times 171, which is 342. So now I could multiply this out and factor it and then set it equal to 0, but I don't really want to go there right now with the algebra. You just have to figure out 2 numbers, probably using guess and check, that are right next to each other that multiply to 342. Anyone tell me what those 2 numbers are? Guess and check. Guess and check. Yeah, I mean, 18 times 7, I think you're pretty close. What are they? 18 and 19. Okay? So, yeah, I mean, really algebraically, what you should do is multiply these out, get everything on the left side and factor it, and then, but I think it's just easiest to say, because you know the numbers need to be right close to each other. If I try 20 and 20, that's too big, right? Because I make, or 20 and 19, that makes 380. But you know you're close. So you go down 1 to 19 times 18. And I know that an 8 times a 9 is going to give me a 2 at the end, right? Because it's 9 times 8 is 72, right? And so this gives you 342. So how many handshakes if 171, I mean how many people if there are 171 handshakes? 19 or 18? 19, right? Get it? Not that hard. So this applies to lots of things, not just handshakes, but like back in the olden days, when they used to have telephone lines, you know, I mean, like everything wasn't I mean, we still have telephone lines and stuff, but like they'd have party lines and stuff, and so you'd actually have to have a physical connection to another phone line to talk to somebody. So it'd be like, how many different lines do I have to have in order so that everyone in the room could talk to each other, you know, and stuff like that. So you can do that. You can think about it as computers talking to each other, internet, all that kind of stuff. Baseball games, if you're in baseball teams, there's, you know, how many teams in the National League? How many different teams do you know? Is it like 27 or something? So yeah, like 27 teams in the National League, maybe 27 teams. Is it that many? Or maybe it's like, there's like 9 in each division, right? So like 18 National League, 18 in the American League, so it'd be 18 and 17 divided by 2 twice, right? That's how many different high school or professional, and you can think about with football games, right? How many different football teams? How many different football teams are there in NFL? 32, so you could have 32 times 31 different matchups, right? 32 times 31 divided by 2, right? So that's a lot of different combinations you could have, huh? Anyway, so that's that. That's the handshake problem. There's another type of problem that you're going to see, and that's diagonals of a polygon, right? And I'll go kind of diagonals in diagonal. There we go. That's not spelled. Let's try to spell it correctly the second time. Diagonals in a polygon. Okay? Polygon, so polygon. So sides, and this is diagonals. So this is a similar pattern, but not exactly the same. So as you notice, these aren't linear patterns like we did in the last case. They don't go up by the same amount each time. It's called the quadratic pattern, where one of the terms is squared. Okay, and so if I have a polygon with one, can I have a polygon with one side? No, so I wouldn't have any diagonals. Can I have a polygon with 2 sides? No. Okay, so I'd have 0 diagonals there. Can I have a polygon with 3 sides?
Yeah.
How many diagonals do I have if I have a polygon? 0 still, right? Because that would be a triangle, right? Triangle, no diagonal. And now I get to 4 sides, and I have a quadrilateral. How many diagonals can I have? 2. Okay, 1, 2. 5 sides. Pentagon. Let's see if I could draw a nice pentagon. I get to cheat. Pentagon, 5 sides. Let's see how many diagonals I have. 1, 2, 3, 4. Does this symbolize something? I don't know. Isn't that like the anarchy symbol or what is it? It's just a star. Okay. So how many diagonals can I have with 5 sides? 5, right? 5 diagonals. So this is 5. How about 6? Try a hexagon. Let's make a hexagon. 6. Hexagon. This thing only goes up to hexagons. Gotta make it bigger. I bet you wish you had your own hexagon drawing tool. Alright. So I'm going to see how many different diagonals. Count them. 9, you think? Oh yeah, because you have 6 sides. How'd you figure that out so quick?
I just did the handshake thing, but minus 6.
you subtract 6 from the handshake thing, right? Because it's a 6 connection. But if you modeled it, right, 1, 2, 3 from that diagonal, right? That shouldn't be curvy. 4, 5, 6. Then where do I go to here? 7, 8. I can't go to this one. I've already used that one. 9. And I think that's it. 3 coming out of every one, right? So that would be 9. 6 is 9. Anyone think about what they, so there's a similar mathematical formula for this. Anyone figure out what that mathematical formula is? Think of it this way. If I have 6 sides, how many diagonals can I have coming out of any one vertex? How many diagonals can I have coming out of here? 3, right? So here I have 5 sides. How many can I have coming out of here? 2, because I can't connect to itself, and I can't connect to here and here because that's not a diagonal. See that? So if I have 7 sides, okay, I'm not even going to draw it, but if I had 1, 2, 3, that's a heptagon, by the way. 4, 5, well, I will try to draw it. 6, 7, 1, 2, 3, 4, 5, 6, 7, 7 sides. There's a heptagon. 1, 2. How many diagonals could I have coming from any one vertex? 4, right? So basically I have 7 minus 3, because there's 3 connections I can't make. Do you understand that? Because out of any vertex, I can't connect to here, I can't connect to here, and I can't connect to itself, right? So it's going to be n minus 3. You follow that? Okay? So it's going to be 4 times 7, because I could do this from 7 different vertices. So I'm going to change this to 7 times 4. Do I have to divide that by 2 as well? Yeah, because you're counting everything. Like over here, we got into double, like I tried to go another one from this one, but this one's already there because I already counted it. So you have to divide by 2. So the formula for diagonals in a polygon is n times n minus what?
3.
N minus 3 divided by 2. Okay, so this is diagonals in a polygon. Diags in a polygon. So n times n minus 3. So for example, how many diagonals in a dodecagon? Anyone remember what a dodecagon is? Anyone? Decagon is 10. A dodecagon is 12. Okay? So what would I multiply? Evelyn, what would I multiply to get how many diagonals in a dodecagon? 12 sides. So what's n? Yeah, what's n? But in a dodecagon, how many sides is dodecagon have? 12. So what's n minus 3? 9. Divide that by 2, right? Which is the same as multiplying 6 times 9, which is 6 times 9. Kira, what's 6 times 9?
Oh,
54.
yeah.
54, thank you. Do you know how to multiply 9s together?
Yeah.
You know that trick
Yeah.
with your fingers? Oh, okay.
Oh, well.
You don't know that trick? 6 times 9? 6, then you put up your 10 fingers. You put down your ninth, you put down your ninth finger. So 1, 2, 3, oh, 6 times 9. You put down your 6th finger. 1, 2, 3, 4, 5, 6. So 6 times 9 is 54. Not very good. 7 times 9 is 63. You didn't know that? You didn't know that? Anyway, it was on a movie I saw. Stand and deliver. All right. So anyway, how many diagonals in a dodecagon? That's how you do that. What if, so going backwards, okay? Going backwards, what if I said, so don't do this on a test. If I say, how many diagonals in a dodecagon? And you start drawing a 12-sided figure, and you start trying to draw in all the diagonals, you're gonna, A, you'll probably get it wrong because you lose track, and B, it's not the best way to do it, you know? Okay, so don't do, like, try to count it by hand. So what if I went backwards, okay? So I'm gonna let you guys try this one. A polygon has, polygon has 35 diagonals. How many sides does it have? How many sides? Go ahead, you give that a shot. Whoops. I gotta pause. Where'd my workspace go? Stop. What did you guess in check? Did you use a formula at least?
Yeah.
What was the formula?
It was
N times
n minus 3
n minus 3
divided by 2.
divided by 2 equals 35. So that means that n times n minus 3 has to be equal to what? 7, right? And then you just say what two numbers that are 3 apart multiply to 7, right? And you said 10 and 7, right? So n would be 10, and n minus 3 would be 7. All right? You get that? Not that. So really, in this homework, there's a couple other ones that are a little different, but most of these are just applying those two formulas. Okay, so it's either n times n minus 1 divided by 2, or n times n minus 3 divided by 2. And this is what they call it mathematical modeling, because it has to do with, you can model a lot of real life things with geometric shapes. And then tomorrow we start, it gets more into the other thing, one more thing. These are called triangular numbers. And especially n times n minus 1, n times n minus 1 divided by 2. These are called triangular numbers. Triangular numbers because I can make triangles out of them. So if I did like 1, 2, 3, 1, how do I do? 1, 2, 3. So 3 times 3, that's not right. Because this makes 3, 5, 6. Here we go. So the first triangular number looks kind of like a triangle. Here's number 1. Number 2 looks like this. There's 3 terms. Number 3 looks like 1, 2, 3, 1, 2, 1, and there's 6 terms there. The fourth triangular number would have 4 things on the bottom. 1, 2, 3, 1, 2, 1, and that makes 10, right? That's 1, 2, 3, 4. So that's what's that? That's 4, 4, 7, 9, 10, right? So that's not n times n minus 1, is it? That's n. 4 times another type of triangular number. So this one we have 1, 2, 3. How many dots would this one have? 15, right? So these are the same numbers. They're just kind of appearing in a different order. 1, 3, 6, 10, 15. All of those are triangular numbers because they would make a triangle. But like the term can be different depending on what you're talking about. Okay, your homework is on Schoology, right? Do you want me to show it to you, or you know what it is? Did anyone look it up and figure out what it is? Yes? No? So So that is your homework, just to show you guys, what's on the assignment sheet. I use that as a guideline, but depending on the day, I go by what the assignments are on the individual assignments on Schoology. Like the assignment sheet kinda tells you general outline and stuff, but I change those things. So this is your homework, page 112, 136, and 12, 3, 22. Then it's on the stuff we just talked about. And that